Today we're going to be focusing on counting principles. And the first type of counting principle we're going to look at is called the fundamental counting principle. And if we were going to do things the boring way, we would go straight to the definition and talk about that. But we're not going to do the boring stuff today, hopefully never. Well, we'll come back to it actually. We're going to actually look at Audrey. And Audrey looks this way because homecoming's coming up, and she doesn't know what to wear, how to accessorize, and it got her thinking, how many different ways are there to get ready for homecoming? And I'm just going to say this, sorry guys, this is about girls getting ready for homecoming, so you're going to have to bear with us. So anyways, Audrey happens to have a good friend named Natalie Portman. And Natalie has 8 dresses that she's willing to let Audrey borrow. And so Audrey goes, you know what, I better kind of keep track of this. So let's see. I've got 8 dresses that I could wear to homecoming. And then she herself has a ton of shoes. And so she clears out her closet looking for the shoes that she enjoys wearing. And you know, she could go funky and wear some sneakers, or go casual, wear sandals she could dance in, or something like that. Alright, so we're looking at 8 pairs of shoes. Hopefully you can see those all in the screen. Well, or not. So she's got 8 pairs of shoes, so she writes down 8 shoes. Okay, that's it. And she's like, okay, necklaces, I'll probably wear one of my Tiffany key necklaces. And so she's got 4 of them. And so she writes down, okay, I've got 4 necklaces. And then she's also going to accessorize with purses. She's got 1, 2, 3, 4, 5, 6 different purses she could accessorize with. And so she gets her paper out again and she reminds herself, okay, I've got 6 purses I could choose from. And then she thinks, oh, my hair. What about my hair? And another one of her good friends, Kate Winslet, stopped by and said, Audrey, don't worry about the hair. I'll come over and fix your hair in one of these 4 different styles. So Audrey's thrilled, of course, and she's like, okay, that's hair. I've got 4 different ways I can do hair. And then the last thing is, which watch of hers should she choose? And she's got 5 watches she can choose from. And so she looks at these numbers and she realizes if she multiplies 8 times 8 times 4 times 6 times 4 times 5, she will get how many different ways she would have to get ready for homecoming. And when she hits the calculator, she gets the dizzying number of 30,720. Okay. So, sorry guys, that's over though. And why did we do this? Because actually, what we just did was the fundamental counting principle. And the fundamental counting principle says to let E1, E sub 1, and E sub 2 be 2 events. The first event, E sub 1, and let's stop and talk about what does an event mean. An event could mean picking out a dress. I know some of us think of events as in going to the movie or even homecoming being an event, but picking out a dress can be an event. So if E sub 1 is your first event, it can occur in M sub 1 different ways. Like picking out a dress can occur in 8 different ways for Audrey. After E sub 1 has occurred, E sub 2 can occur in M 2 different ways. For instance, event number 2, E sub 2, could be picking out shoes, and Audrey also had 8 options to pick out shoes, so that could be 8 could be M sub 2. The number of ways that the 2 events can occur is M sub 1 times M sub 2. So in our case, there were 1, 2, 3, 4, 5, 6 events, and that's why we multiplied those 6 numbers. So just doing something as intuitive as that is what the fundamental counting principle is all about. Okay, which lets us move on to the next counting principle. And so wonder if your assignment was to go to the local shelter and pick 3 cute dogs to take home. I know my daughter would love that if that were her assignment. So let's say that we've got the dogs, and I'm going to probably have to zoom out so we can get these dogs. let's say that you had, let me zoom out a little bit. Okay, so it wasn't letting me zoom out while I was recording. So here we go. I placed all 6 puppies, and your homework is to pick 3 of them. And it just starts you thinking, oh, I wonder how many ways this can be done, because, you know, I'm not really a good decision maker, and gosh, there's so many, they're so cute. And so you start to think, well, I guess I could pick these 3. You know, that's one way I could do that. Or I guess, you know, I could pick these 3, or I could pick these 2 and this one. And it makes you start wondering, because, you know, you love math so much, how many ways can I pick 3 of these dogs? And so one way to do it is to actually go through until you've exhausted all the possibilities and you'll have the answer. But another way to do it is by using NCR. And we're familiar with NCR because we've used it to find the coefficients for our binomial expansions. And we call NCR combinations. That's another way of using a counting principle, is using combinations. And so NCR in this case would be, well, I've got 6 dogs and I'm choosing 3 of them, and I want to know how many ways can that be done. So for NCR in this case, it would be, let's get a sheet of paper, we'd have 6 dogs, and we're choosing 3 at a time, and we want to know how many different ways we can do that. If you do this on your calculator, you know that your answer will be 20. And if you really want to know what's going on with NCR, you can compare it to the fundamental counting principle, which says this. Wonder if picking the dogs, each dog was an event. Picking the first dog, then the second dog, then the third dog. Well, with the first event, we'd have 6 dogs to choose from. So we'd have a 6 here. We've already chosen one, so by the second choice, we'd have 5 left. And then the third choice, we'd have 4 left. And then you're going, wait a minute, that doesn't look right, because that's going to give me 120. Okay, so we'll put that equals 120. And you're like, there's no way we have that many combinations. The reason why that doesn't work, because we're not done, we've got to do something to this number, because really what this number means is this. Let's say that we picked, trying to scoot everything over, let's say that these 3 were the dogs that we picked. We picked this one first, then this one second, then this one third. That's great. That should count as 1, right? But using this, the fundamental counting principle, that doesn't just count as 1, because wonder if I picked that one first, but this one second, and this one third. Ah, there's another choice. But not really, right? If I take these 3 home, I'm still taking these 3 home. Or maybe, gosh, let's do this one first, and this one, and this one. So then we have to stop and think, wait a minute, given 3, how many different ways could I pick those 3? And so what we have to do to our answer is divide. To make a bigger number smaller, because we know our answer really is 20, we're going to have to divide. And what do we divide by? Once again, picking 3. I know that if I'm picking 3 dogs, I have 3 ways to do the first one, 2 ways to do the second one, and 1 way to do the third. And so I end up with 6. So 3 times 2 times 1 is 6, and 120 divided by 6 is 20. Now, for some of you, you probably didn't need that second part. You're just happy as can be to put in the 6C3 and you get your 20. But for others of you, I think and I'm in that group, that second group. I want to know why. And so this is what combinations are about. First of all, you're going to be reading problems in your homework, and you're going to have to say, okay, do I use the fundamental counting principle, or do I use combinations? And then you go ahead and apply what you think you need to do. So the understanding why is important. Once again, we could solve this problem using NCR, and the problem was, in how many ways could I pick 3 dogs from 6 total dogs? Do it NCR, or do it with the fundamental counting principle, and then kind of adjusting. Alright, so let's say instead of the homework being, oh, just pick 3 cute dogs, wonder instead you got the same dogs, but now you've got to place them in order of cuteness. And you've got ribbons, first, second, and third place ribbons. And so when you're looking at these now, all of a sudden, let's just say I pick the same 3. Okay? So I pick the same 3 and I say, oh, he's so cute. He's first, and I don't really like the little dog that much, so he's third. I'm sorry, he's first, he's third, and oh, he's cute, he's second. Okay? So that's one way that I could place 3 dogs in order of cuteness. These same 3 dogs, however, it would be a different result, right? If I said, oh, really, look at that face. He's number 1. And you know what? Oh, he's so cute. He's number 2. He's still number 3. This is a different result. So when you're asked something like, out of 6 dogs, and let's get the other 3 here that were really, really adorable. Oh my gosh, he's adorable. If you were asked out of 6 dogs to place 3 in order of cuteness, and you wanted to know how many ways you could do that, you'd have to use something different than combinations. You'd have to use, instead of NCR, you'd have to use NPR. And those are called, when you use NPR, it's called permutations. And if you want to know what we're really doing, it's this. We're going back to the sheet. This was our original sheet when order didn't matter. None of these dogs were first cute, second cute, third cute. They were just 3 dogs you're taking home. In this case, we're doing the same thing but with permutation. So we're taking 6 dogs and we're picking, and the P doesn't stand for picking, it stands for permutation. We're picking 3 dogs, but we're picking them in order. First cutest, second cutest, third cutest. So the order does matter in how we're picking them. And so 6P3 is going to be on your calculator. And when you do that, you're going to end up with, I believe, the 120, which looks familiar, right? It's the same as this 120. And the reason is, when you think about first, second, and third place, think about it. Out of 6 dogs, if you're choosing first place, how many dogs do you have to choose from? 6. Second place, 5. Third place, 4. So when you look at 6P3, you can put it in your calculator and you'll get 120. Or if you want to really understand what's going on using the fundamental counting principle, you can go ahead and use this. It gives you the same answer. So it's nice to know that you can do it 2 ways. So I highly encourage you to do it the permutation way. Okay, some people get confused and can't remember that with permutation, order matters. So I always tell them a cute story. Well, I think it's cute, so I'm going to tell it. You know, I went to college in the 80s, and I really did my hair up big. And one of the things for doing your hair up big is most girls that did big hair got perms. And so if you've never heard of perms, it's a process. And first you come into the salon and they roll your hair up in these little bitty rods, and then the salon person squishes out some really, really stinky formula stuff. And then she puts it all over your hair and the rods, and then she has you sit underneath a dryer, you know, one of those old-fashioned dryers. Actually, they're still in the salon. And then when you've waited a certain amount of time, then she takes the rolls out, the little rods out, and she washes your hair. And after that process of rolling, putting the stinky solution in your hair, sitting underneath the dryer, and then getting it washed out, you have beautiful waves. Okay? So it made me think about, you know, perms and how, you know, wonder if one day you went in and maybe your lady hadn't given a perm before, or maybe, I don't know, it was the 80s, I'm not sure what was going on with her. So maybe instead when you came in, she said, you know what, first I want you to sit underneath the dryer, and then I'm going to put the yucky solution in your hair, and then I'm going to wash it out because, whoa, that was stinky, and then at the very end I'll just put some rollers in your hair, and you sit there. So she changed the order up. The dryer, then the stinky solution, then the hair washing, then the rolling the curls. And when it all is said and done, you don't really get a perm. Why? Because with perms, order matters. Just like with permutation, order matters. So just to clear things up, when you have a choice between combinations and permutations, you look to see if order matters in the problem. If the problem says, in how many ways can you pick out 3 cute puppies, in how many ways can you pick out 3 puppies from 6, order doesn't matter how you choose them. But if it says, in how many ways can you pick out the first, second, and third cute puppy from 6 puppies, then order does matter. It matters which puppy you pick for which prize. If it said, pick out the president, vice president, and secretary out of a group of 20 people, and in how many different ways you could do it. I mean, there's a difference between getting picked for president and getting picked for secretary. So order does matter. It matters. So if order matters in your problem, then you're going to pick the permutation. You're going to do an NPR. And we're almost done. There's one other type of permutation problem, and it's called distinguishable permutations. Hopefully you can see that. And basically with distinguishable permutations, it'll say something like this. In how many ways can you write a word, and I'm using quotations, you can't see me, a word using the word banana. And so the words aren't going to be real words. It's kind of like one of those birthday party games we used to play when, I don't know, in elementary school. But this time it's not real words. It's just saying 1, 2, 3, 4, 5, 6. We have 6 letters to pick, and we're going to just see how many times we can write something, fake words, out of those 6 letters. And so, maybe you would write O-N-A-A-N-A-B. Whew! Okay, that's one. And we keep going on and on. But, my favorite would be this. I would write B-A-N-A-N-A. And then my next favorite would be B-A-N-A-N-A. What you say? You say I'm writing the same thing twice? No, I'm not. I am not. In this one, this A is here, and that A is there, and then this one I switched them around. Like now I wrote this A is here, and that A is here. What? You're saying that doesn't make a difference? Well, sure it does. And I'm going to write it another way too. And this one, I switched those ends around. Okay, you can see where this is going, and that's why we've got the word distinguishable. Because even though, maybe you'll fall for I move the ends around or I move my A's around, they're not distinguishable. One banana looks like another. Okay, so distinguishable permutations mean this. We're going to look at the word banana, and first of all say, okay, I've got 1, 2, 3, 4, 5, 6, 6. So we've got 6 lines. 1, 2, 3, 4, 5, 6. And how many letters do I have to pick for the first one? I've got 6. How many for the second one? I've got 5, then 4, then 3, then 2, then 1. But there's a problem. If I multiply these out, that number is going to be actually larger than the real answer. And so to make it smaller, I'm going to have to divide. And I'm going to have to look at something like the A's. Okay? If this AAA, oops, it's not in the screen. If AAA is no different than AAA, even though I just switched the first two, and no different than AAA, then I have to go, how many times can I write AAA? Well, 1, 2, 3, I have 3, 2, 1. I can write it 6 different ways. It doesn't matter that I can write it 6 different ways, only one of the ways counts. So to accommodate for that, I'm going to have to divide this big number by 3 times 2 times 1. So that took care of the A's. And now the N's. I look at the N's. There are 2 N's. And once again, I could write NN or NN. I could actually just write it 2 different ways, right? So to accommodate for that, I'm still going to think of the fundamental counting principle. It says if I have 2 things, like 2 N's, I've got 2 N's to pick from for the first pick and only 1 left for the second. And then you go ahead and multiply the top, multiply the bottom. I'm going to do this by hand because I don't have a calculator in front of me. The 2 and the 2 cancel, so I'm going to end up with 20 times 3 is 60, and that's our answer. And that's the general lesson for today. I look forward to seeing you in class because that's when we're going to have fun. We're going to be looking at a lot of different context problems where the most difficult part of this section is going to be deciphering which method to use, whether we use the fundamental counting principle or permutations or combinations. Look forward to seeing you in class. Thanks.